Question number 59. Find the charges on four capacitors of capacitance 1 microfarad, 2 microfarad, 3 microfarad, and 4 microfarad shown in the figure. This is 1 microfarad, this is 2 microfarad, this is 3 microfarad, this is 4 microfarad. This resistance 3 ohm, this is 3 ohm, this is 1 ohm, this is 2 ohm, this is 6 volt battery. So, in a steady state, these capacitors will behave like open circuit. So we can draw the equivalent circuit. In that case, 6 volt, this is 1 ohm, this is 2 ohm, and here this is 3 ohm, and this is 3 ohm. Now we have to find out what current flows from here. So here it will be I1, this is I2. So let's find out what is I first and then I1, I2. So total resistance. So here 1 plus 2, 3 ohm. This is 6 ohm. When these two are in parallel. So R equal to 6 into 3 divided by 6 plus 3. That is 2 ohm. So value of I will be 6 upon 2. That is 3 ampere. Now for this branch, we can find I1. So I1 will be equal to 6 by 3, that is 2 ampere. And I2 will be equal to 1 ampere. Now, potential difference across 1 ohm resistor will be Pg across 1 ohm is equal to, since current through 1 ohm is 2 ampere, so it will be 2 volt. Now, we can find a charge on 1 microfarad capacitor Q equal to CV. So we write it as Q1. So C1 times V. So C1 is 1 microfarad, 1 into 10 power minus 6 into 2 volt. So it will be equal to 2 into 10 power minus 6 coulomb. Now, PD across this 2 ohm resistor will be is equal to 2 into 2 because 2 ampere current flows through this wire. So 2 into 2, that is 4 volt. Now, charge in this capacitor, say just Q2 is C2 into V2. So C2 is 2 into 10 to the power minus 6 into V2 is 4 volt. So that will be equal to 8 into 10 to the power minus 6 coulomb. Now, current through this capacitor will be equal to, it also join. So current through this resistor, so PD across 3 ohm resistor is equal to, suppose it is V3. So current flowing through this is 1 ampere. So it will be 1 into 3, that is 3 volt. So charge Q3 stored in this 3 microfarad capacitor will be C3, V3. C3 is 3 into 10 to the power minus 6 into voltage is 3. So it will become 9 into 10 power minus 6 coulomb. And here, PD across this 3 ohm resistor, PD across 3 ohm resistor will be V4, and that will also be 1 into 3, that is 3 volt. So charge Q4 will be C4 into V4. C4 is 4 into 10 to the power minus 6, and V4 is 3, that is 12 into 10 to the power minus 6 coulomb. So this is answer. Now let's go to next question. Find the potential difference between the points A and B and between the point B and C in the figure 32, E33 means this figure in a steady state. So let's evaluate total capacitance. So these two capacitances will be in parallel, and these two capacitances will be in parallel. So let's draw the equivalent capacitance. So this is 1 microfarad, this one, and then here these two are 3 microfarad. Then here there is point B, and then two capacitances, 1 microfarad and 1 microfarad. So one, this is 1, and this is 3, this is 3. So these two will become 6. So this is 6, this is 2, then this is 1. Now we evaluate it. So these two will make 6 into 2 divided by 6 plus 2. So that is 3 by 2 plus 1. That is 5 by 2 microfarad. So we have got equivalent capacitance, and here voltage applied 100 volt. So we can calculate charge on each capacitor. So for this purpose, we can find total charge. So Q equal to CV. So equivalent capacitance, this is C equivalent. So C is 2.5 into 10 power minus 6 into 100. That is 250 into 10 to the power minus 6 coulomb. So this is total charge. Now we have to find out charge stored on capacitor 1 microfarad. So let's find out Q equal to, suppose Q equal to C1 and then V. So C1 is, this is 1 microfarad. So 1 into 10 to the power minus 6 into voltage for this capacitor is 100. So this will be 100 into 10 to the power minus 6 coulomb. Now the remaining charge, total charge is 250 into 10 power minus 6 coulomb, and the charge on 1 microfarad is 100 into 10 power minus 6 coulomb. So Q2, that is remaining charge, will be equal to 250 minus 100 into 10 to the power minus 6 coulomb. So that will be for this capacitance and this capacitance. So this will be 150 into 10 to the power minus 6 coulomb. Now, for this portion, we can find the charge. So suppose this is Q2. So it will be equal to C2V2. So we have to find out the voltage for this. So voltage will be equal to C2 is for this we are going to find the voltage. So it is 6 into 10 to the power minus 6 into V2. So V2 is to be found, which is equal to Q2. Q2 is 150 into 10 to the power minus 6. So from here, we will get voltage across this 6, means you combine the result of this, it will be equal to 25 volt. Now, since total voltage applied is 100 volt, so voltage across this will become, suppose this is V3, so this becomes 100 minus 25, that is 75 volt. And our concern was to find the voltage between points A and B. That is, this is A, this is B. So as we have seen, voltage drop across this 3 or 6 microfarad capacitor is 25. So we can say the answer to first part, that is voltage between V and sorry, voltage between A and B. So let's write it as VAB. That will be equal to this 25 volt. And voltage between B and C means here there is potential drop, or here to combine result, potential drop is equal to 75 volt. So VBC is equal to 75. And that is our answer. Thank you for watching.